Hey everybody, my name is Mark Borschi. I'm the co-author of Kubernetes, an Enterprise Guide, second edition, along with my co-author Scott Surovich. And for this book, we thought we'd have a little fun and actually do videos of each of the chapter's labs. One of the things that I think makes this book so unique is that it's a mix of both practical labs based on our experience deploying Kubernetes across multiple enterprises and also theory. But the labs can get kind of complex, and so we thought it'd be great to have a video for each chapter so people could see what the end result looks like, something they could compare it against. So we're going to start today with chapter 1, Docker chapter. Not a lot to demo in this one. If you are familiar with the first edition of the book, we got rid of most of the Docker content, especially given the fact that Kubernetes was deprecating Docker shim, which is what allows you to use the full Docker daemon with Kubernetes. And so in this edition, we trimmed that down to basically just enough Docker to be able to say, okay, let's get a Docker container running on our local laptop, how to interact with it, especially as we get later in the book, Kind, which is Kubernetes and Docker, being able to interact with Kind. So what we're going to go ahead and do is launch Docker. We're going to install it onto our VM and run a couple commands. So that said, I've already got my Ubuntu 2004 server going. So the first thing we're going to do is go ahead and check out our code from Packet's GitHub repo. So I got it right here. And obviously, if you are on the book or you're looking to get the book, there's a link in there as well. So git clone that. Now, if you take a look in the book, there are a lot of manual steps for installing Docker. It's kind of hard to do that with this book or with any book. And so Scott Surovich, who wrote this particular chapter, did a great job, and throughout the rest of the book, to be honest, of building scripts that take all those complex steps and putting them into one script. So we're actually just going to go ahead and take a look at that script real quick, and then we're going to run it. So it's install docker.sh. And what this script is going to do is it's going to set up a Docker user. It's going to go ahead and install all the certificates that you need to install Docker, add the repo, install Docker, enable it, and then go ahead and make sure that our current user can use Docker. So that way we don't have to sudo to root in order to interact with Docker. To make that part work, you're basically telling Docker anybody in the group Docker can access the Docker daemon, and then our current user can access Docker. So why are we going through that? Just as a real quick review, Docker is a daemon. It's a background process. It accepts network connections. So if you're thinking about maybe newer tools like Podman, don't require that daemon. You can do a lot of the things with Podman or that you can do with Docker, but you can't do everything with Podman that you can do with Docker. So Docker is still our kind of go-to interact with containers locally tool. So that all said, let's go ahead and install Docker. Okay, so we have our script has been run. And let's see, can we log in and see it? Yep, so I ran Docker PS as a unprivileged user. I'm not root, just prove it. Okay, so let's go ahead and go through our tutorial here. So the first thing we got here is Docker run. So we're gonna go ahead and run a container. And in order to do that, we're gonna go ahead and run Nginx from Bitnami. That Bitnami is, I think it's part of VMware now, and they have packaged up all sorts of containers. So let's go ahead and run this command. I'm on chapter or page 15. So Docker run d Bitnami Nginx latest. So we're going to run Docker container. And the -d means that it's going to kind of run in the background. So it's saying, okay, can't find it. It's pulling the image. Now you'll notice that all these different things, these are the different layers. That's one of the things that makes Docker so unique. Containers existed for a long time before Docker came around, but Docker really made them easy to use. And so one of those things is being able to have that copy on write, those multiple layers of the image. And so what we can see here is that all these different images were now downloaded. So now let's run the next command, which is, okay, let's take a look at what we got running. And so our container is running. It's been running for about 27 seconds. It's got a couple of ports open, and it's got kind of a funny name. Docker will assign names automatically. If you don't assign a name to the container, it'll get named automatically. And so we just ran Docker PS to see that, in fact, we did have a container running. So that was on page 16. And so we're going to go ahead and see what we can do to interact with this container. So the container is running as a background process. So like any other system level process, you can start it and stop it. So you can do a Docker stop, and you can do it by either container ID or name. And it's stopped. So let's go ahead and start it back up. Now, containers are ephemeral, which means that nothing is persisted outside the runtime of the container. That said, if you start and stop a container, anything that you have added to that container will exist and persist. What will go away is when you eventually kill and remove the running instance, that will eliminate anything that you created inside of the container. So the next thing we're going to do now that we've started and stopped our containers, we're going to attach to it. This is an important concept because over the course of your work in Kubernetes, you will often have to attach to a process in order to debug it, whether it is to debug a network connection, debug credentials. A lot of times, especially in enterprises, you're not dealing with open network topologies. You're working with isolated network topologies. So you need firewall rules in place to be able to access different network resources. So even though something works from your local workstation, it might not work from your pod. And so you'll need to attach to that process to either see what's going on directly or exec into it. So we're going to look at that first. So let's go ahead and attach. So I'm on page 18. All right, so we're now going to go ahead and attach to our running Docker container. Attaching means that we're going to actually connect ourselves to the running process. So whatever that process is doing, whatever that output is, we're going to see it. This is different than exec, which we'll show in a second, which means we're going to create a new shell running inside that process's name context, so we can actually interact with our environment the way that our container sees it. So the first thing we're going to do is go ahead and attach, and we see that there's not a whole lot going on because nothing's hitting our web server. So we're going to go to another tab now. I'm logged in, and I'm going to now exec into this container and run the curl command so we can hit the web server. Now, why do I have to exec into this container and not just hit our web server that's running inside of a container from anywhere? Well, we didn't tell Docker to expose the ports, so you can't access it from outside. So I'm going to go ahead and run this curl command against our same container ID. And we got something back. So what we actually did was we opened up a shell inside of our container, running in the same process space as our container. We ran the curl command. Curl is installed on the local system. Got back the welcome to Nginx. And now if we come back to our container, you'll see that it actually logged the output because we're attached to the exact same container or the exact same process that's running. So one thing to note here, that if we hit Control-C, it's actually going to stop the container, which is kind of fun. Watch this. So I'm going to hit Control-C to get out. but I'm going to run Docker PS. Container's not running. Let's go ahead and start that back up again. And so now we're back up and running. And so the next thing we're going to do is look at logs. So Docker lets you, instead of attaching to a process to see the existing logs, lets you look at the logs that are being generated. Docker will generate logs either to a text file on the system or out to something like FluentD or Splunk or whatnot. We're not going to get too much into the way that Docker handles logs because we're primarily concerned with Docker as a development tool, not as an enterprise system. So if we want to go ahead, and I'm now on page 20 and see what it looks like, you can do Docker logs -f. So you can now see all the logs from the container and what is actually, being generated in real time. And let's go ahead and run our exec again to get something from curl. And you'll see that we now have a new log line. So we're actually now seeing the logs as they're being generated. But when we hit Control C, we're not going to detach from the process. So this is a lot safer way to be able to get logs. So let's go ahead and stop our container. So we've stopped the container. However, the container is still there. It's just not running. There are two aspects to a container. There is the image, which is just a tarball of tarballs. Tarball is a way to store files. So each layer of your image is a different tarball, including that top layer where whatever changes we're making are being stored. Just like when you run a process on your laptop or on a server, anything that gets written to disk is still there once you stop the process. So the next thing we're going to do is actually remove the image. And now it's gone. That's on page 21. So with our Docker image removed, if I go ahead and do Docker start that same image, it'll fail because the container doesn't exist anymore. Anything like, let's say we had added web pages to this container, they would now be gone. They wouldn't exist anymore. And so that's where things like volumes will come in as we get into Kubernetes and externalizing your content from your containers. So that's it for chapter 1. It was kind of short, really quick, just how do you get Docker up and running? We hope you enjoyed it and look forward to hearing from anybody who has some feedback. We love to hear it. And thanks for coming by and look forward to seeing you again for chapter 2 when we install Kind.